everyone. I'm Marcy Collinson, Director of Worldwide Academic Research at Microsoft. Welcome to the Microsoft Academic Research Exchange Series. This series aims to explore customer and partner use cases for scientific research scenarios with use of Azure services and solutions. We believe that facilitating a forum where researchers can engage in expert-to-expert conversations will help them to discover solutions and resources that will advance their time to scientific discovery. At any time during this presentation, you're welcome to submit your questions using the live meeting chat. In this episode, Felipe Ayora, Director of Research and Advanced Computing for BizData, will share an overview of the BizData platform Loome, supported by customer use cases, followed by a demo. Felipe, please take it away.
Hello, and welcome to the Microsoft Academic Research Exchange. I am Felipe Ayora. I'm a Director of Research and Advanced Computing for BizData. So first of all, just a little bit about me. I was with Microsoft for almost 15 years before I joined BizData. I started in Redmond in the Windows Server High Performance Computing team, then in the Azure High Performance Computing team, and I had the opportunity to come to New Zealand because of an acquisition of a small high performance computing company here. And I honestly fell in love with academic research. I moved to the education team and because I wanted to be dedicated to the research, especially the academic research world. And after a few years, decided that I wanted that to be my full-time job. So I joined BizData about 6 years ago to implement this platform that I'm going to talk about today. It is called Loome, which is specifically targeted to researchers. And I get the privilege of working with researchers all over the world now on a day-to-day basis. So let me tell you a little bit about BizData. It's not a brand new company, but it feels like one. We're very agile. We have around 17 years. We used to have offices in many places, but everybody is working from home after COVID. So that has been great, actually, because it opened the world, to be honest, to us. It's much easier for me now to work with customers in Austria, in the Middle East, in the United States, literally all over the world. So that's been great. We specialize in anything related to data. So we're kind of a very much a specialized Microsoft partner when it comes to the technologies that we use. My particular team looks after research, high performance computing. We do a lot of genomics workloads, but as a whole, the company does basically data intensive application analysis and platforms. And we've been a Microsoft partner for many, many years. So we have all the accreditations and specializations and even have had some awards throughout the years. We have customers, as you would expect, in 17 years in many, many different industries. They don't all fit here, so this is just a quick snapshot of some of the most recent customers. My team tends to be working with customers in the top left corner, education, research, health. Of course, some customers as well in not-for-profit, but there's also high-performance computing, mining, and oil and gas. So we cover a little bit of a wide spectrum of industries, but BizData in itself basically has throughout the years worked with customers in, you could say, any industry. And you would see some customers there from Europe as well as from Oceania and from the United States. And that's that kind of worldwide customer base that I was mentioning earlier. So how do we, my particular team, help you with research? We like to say that we help you accelerate research, and we do it in 3 ways. The first one is we have the Loome platform that I'm going to do a demo about. That's the one that I joined BizData to create. We also provide hands-on support. We don't just, sell you the platform. We support you with the platform. And that includes working directly with researchers. On a day-to-day, honestly, I work with 1 or 2 researchers at least. And that means helping them select the right resources to do their analyses. My team has bioinformaticians that can help them with their pipelines, you name it. So basically, we can actually work with the researchers. Right? And you choose, how much you want us to be those extra hands to help you with your researchers. And then we also can build custom solutions, and we do that a lot. I mean, BizData as a whole does that a lot because we're an integration partner for Microsoft. But once in a while, we have a customer that needs something very, very specific for research. We can also build it. And now I'm going to talk about a use case related to that. So let's talk about the Loome platform. Like I said, the Loom platform came from my passion for working with researchers, in particularly with academic research users. And there was a common theme. Everybody used to call it the research portal. IT or the people supporting the researchers said, I want a platform where I can let researchers be researchers, experiment, look at new technologies, and just run their analyses and their modeling, whatever they need to do. But at the same time, I want to help them to be secure, to be compliant. So I want a portal somewhere where they can go and pick the right tools for the job, while I can keep an eye and make sure that they don't have to worry and I don't have to worry about what's going on. So it was created with this concept of projects, right? Projects have a budget, and a budget has alerts. So very upfront, it's about cost. So you don't have to worry, they don't have to worry. Within a project, you can pretty much deploy anything that you can deploy in Azure. And that's because we built Loom as an integration platform, as a framework, if you may. It does quite a bit out of the box, but I'm going to talk about that in a little bit. The power of it is this ability to create templates. And that means templates to provide self-service compute, self-service high-performance computing, or even completely automated pipelines. So everything under the same Loom platform. Of course, storage is critical for research. A lot of research data is now moving to the cloud because of cost and the facility of archiving that long term. So we provide pretty much any storage solution that Microsoft offers. We also are big on collaboration, as expected. Researchers are always collaborating internally and externally. So we have a close integration with Teams. I'm going to mention that in a little bit. But also you can share projects and you have roles within projects. So a project really becomes that place where resources are available, but where also collaboration can happen. And everything is done with templates. That's the beauty of it. So normally you start with a few templates, and over time you build a vast catalog of solutions. And many of them are just deltas from the original template. So it's very little effort over time to keep growing that platform. And the other beautiful thing is, if Microsoft tomorrow has a new technology that a researcher wants to access, you can literally deploy it tomorrow as well. And everything is deployed in your Azure subscriptions. We don't take your data. We don't run your compute. It's everything on your tenant subscriptions and whatever you choose to do. So I tried to explain a little bit with this image what I'm talking about. And imagine that that box at the bottom is Azure, right? And I used to say hundreds, now thousands of services and VM sizes and you name it. What we provide is basically a veneer. We provide a user-friendly abstraction on top of that, so that a user can choose from a catalog of resources, and you, as an administrator, and whomever is supporting the researchers, can pre-select what makes most sense for them, and also look at automation options or containerization options. So what happens over time then is that this catalog keeps growing and growing and growing as you add your custom solutions, as you add automation, and it becomes your Loom. And that's why I was mentioning earlier that it's more like a framework, an integration platform. We are integration partners. And to be honest, when I joined BizData, I realized, after talking to institutions in many different places, literally all over the world, that everybody's different, right? Some institutions have a lot of high performance computing, others have more modeling and analytics, others have a lot of genomics. There's no one solution that fits everyone. So we wanted it to be as flexible as possible, so you can make it your own, and also so it can grow and evolve over time, because technology is changing all the time. The GPUs are all the rage, but now it's also AI. So I want to deploy AI services. You can deploy AI services with Loom. So this, and I've seen this personally, really changes how research is done. Normally, researchers have to adjust their research to the resources that are given to them. This flips that paradigm. So now the resources adapt to fit what the research needs. So it's fit for purpose, truly fit for purpose. because of this huge catalog that I talked about earlier. So, for example, a researcher might deploy a workstation to prepare workflows or analysis or to test tools, and maybe they can take advantage of high performance computing so that they deploy a small cluster to experiment, a few cheap virtual machines that cost pennies to run by the hour, but only when they're ready, that time when they're right before the conference or they need to publish the paper, then they deploy a proper HPC cluster or a cluster with really large VMs that have a lot of RAM or whatever is needed for the research workload itself. Obviously, you run it, you get your results, you turn it off. That's the beauty of the cloud. But more importantly, there's very little overhead for the IT team or the team supporting the researchers, because these are not shared resources. They're individual resources. They're project resources. So they can have root access to researchers. That means they can install, configure, change. They break something, they delete it, they deploy it again. You've provided, the parameters under which this can be deployed, and you can stay assured that nothing's going to happen. But they have that freedom to experiment and the freedom to select what is the best fit for the purpose that they want to achieve. I mentioned very quickly that we integrate with teams. Very early on, we were integrating with teams kind of from Loome to Teams in the way that we would deploy a team in Teams every time you create a project in Loome, so that then researchers can use Teams for collaboration. Document libraries, a great place to put documents. But we work with the Microsoft Teams engineering team because they learned about our platform and they said, would you be able to create a fully integrated experience? And they have the Office Marketplace. So we created an app for Teams that has Loome. What that means is that you can deploy a project or a team in Teams, and you can actually deploy a high-performance computing cluster, an AI service, anything that you can deploy with Loome, anything that's available on Azure, you can deploy it, manage it, and use it in the context of Teams. So if your organization is a heavy Teams user, you can give them a completely clean experience without ever leaving Teams. The other thing that came up when I was talking to researchers and also to the institutions they worked in is that they really wanted to have the ability to keep track of budgets and costs, but in a very flexible way, because every institution does it slightly differently. And we incorporated that in Loome, but by taking advantage of what the Azure platform has to offer. So we're not reinventing the wheel, we're basically using the Azure platform's capabilities. So you're probably all familiar with subscriptions. We have a concept of accounts in Loome, and you can have many accounts pointing to one subscription, and accounts are how you track costs within Loome, but everything goes to one subscription. Or you can have a relationship of one account, one subscription. So for example, you could have most of your researchers in one or two subscriptions, and each one with their own account. You can have a team that has one account and they have a separate subscription, and you let them self-manage and control their costs and their budgets. Or maybe you have a researcher who got a fantastic grant and you want to completely isolate them and put them separately so that they can track their costs and audit every single thing they do. You can also do that, everything under the same platform. So we make it very, very flexible. As I was saying, budgets, alerts, but everything's customizable. So the projects, when you set the budgets, you set alerts per project. They're kind of global alerts thresholds. Let's say you say every time that a project hits 90%, I want all administrators to be notified, or 100%. But also the researchers can set alerts. If they're a little bit extra cautious, they might want to set it at 60%. So it's per project, and it gives a lot of flexibility. Emails are sent, they're notified, but also it's very clear what the costs are, as you're going to see in the demo, because we show individual cost resources as well as project resources. And if and when someone exceeds the project budget, they temporarily lose access to their project. So they will click on the project and say, terribly sorry, you're over your budget, please contact your administrator. We do not delete or stop resources by default, but that is doable. We can work with you to set that through, again, the platform, through Azure Automation. And that's because we tag everything. So we can tag resources that are part of a project that is over budget. That allows administrators to not just set budgets and controls and alerts, but also to select the best resources for researchers. So instead, perhaps the most expensive, latest GPU machine, which might be very expensive and really not get much use of it, you select a slightly older version, and that's what the researchers have access to. And that way, the researcher also doesn't have to worry that they're paying for something that they're not going to take full advantage of. So you can control costs by curating that catalog of resources I was talking about earlier. And because we tag everything, not just when resources are over budget, but every time something is deployed, we say what account it is, who the project owner is, cost center, and data classification level. We can then take advantage of what Microsoft offers in terms of cost management. So you can create really good reports and dashboards, alerts, you name it, and even integrate that with third-party tools that, as you know, integrate with that kind of functionality in Azure. Then security obviously is very important. Many of the research data is particularly sensitive. So we do not keep the credentials. We do B2B authentication, meaning that when a researcher logs in, they come to us and they log in with their university credentials or their institution credentials. We send them, through the B2B method in Microsoft Entra, we send them to authenticate with their institution. They would see the splash screen, they would see the multi-factor authentication that the institution has in place, and all the password management, everything happens in the institution. If and when they're properly authenticated, then they come back to us. So it's a SaaS service. So we only keep a tab of who can access and what can they access within Loome, but everything else is kept in your Entra tenant, and all the authentication is done like they authenticate to Office or anything else that Microsoft Entra authentication is used. The other thing that we do is when someone is working in Loome and has access to resources in Azure, we don't add those users to Azure because that would enable them to circumvent, if you may, Loome. They could just go to the portal or Azure.com and see their resources and maybe do things that you didn't want them to do. So we do not add them. There's always kind of a proxy in between, and that proxy is Loome. So you can really control and kind of sandbox what they do from Loome without having to worry that there's a simple way to circumvent that. And the other thing is because we kind of layer everything, like I was saying, that abstraction layer on top of Azure, you can have any infrastructure and connectivity that you require. Let me tell you a little bit more about that. So, for example, you might have really low sensitive data, and for that you go, you know what, that's fine. Researchers should be able to access that over the internet. So you have, I don't know, compute resources that have a public IP address. Not very common, but in some cases it's helpful for collaboration and other things, maybe for experimentation. More commonly, you have medium sensitivity data, in which case researchers can only access that data and those resources that would be deployed in the platform through a VPN connection, or only when they are on premises. So, in the local network. So that can be done as well. Or you can even have a highly restricted environment where the only way to get it through a Jambox or a Bastion. But everything can be done in the context of Loome and the same tenant. And even more, you can have all three or a combination of them under the same tenant. Because what we do, because we layer on top of the infrastructure, you can have, let's say, a subscription with a secure VNet and all the controls to jump hosts and Bastion to get to it, and another subscription where you have less limited access over the VPN. They both work under the same one, and you just restrict through account which researcher can go to which one. So everything under the same one. And that brings us to trusted research environments. A lot of people are talking about trusted research environments lately. And one thing that I've seen is that they tend to have two flavors. Either they are about data, where there's a secure way, a controlled and access restricted way of finding data sets and then requesting access and some kind of way to get access to those resources in encrypted storage, data resources. Or it's the compute side of things, where It's like I was saying earlier, that very secure environment that you can only access through a bastion or a very specific secure VPN. And it might not even have external connectivity or very limited connectivity to the internet, and maybe a very constrained set of solutions because of security. Well, Loom is different. With Loom, because we are an integration platform, our trusted research environment is actually a combination of both. We can provide rich workflows with data federation, meaning that we don't copy the data to Azure. We just index the data remotely. And when a researcher requests access to the data through a workflow that's custom to your business processes, we can actually copy that. Only then we copy the data, and we can actually de-identify the data on the fly. So the data that makes it to the secure computer environment is de-identified based on the requirements of the data custodian. And only then can the researcher access that data by deploying a resource in that secure and isolated computer environment. But because we can deploy anything that's available on Azure, then you can really select between, services and infrastructure, obviously taking into consideration security, and perhaps you don't want data to leave, so you might have to put everything on a secure VNet, but that is doable because we're just layering on top of Azure. And we've done this. We've actually done this for one of our customers. So our trusted research environment was born from a collaboration with Deakin University and Barwon Hill. Barwon Hill is a large hospital system in Melbourne, in Australia. It's around 40,000 patients every year. And the researchers in Deakin University wanted to have access to the routine medical care health data in the hospital, but the hospital obviously wanted to keep that data as secure as possible at all times. So what we did is we built the Loom TRE from this real world scenario. Loom orchestrates data access and workflows, so that enables researchers to come into the Loom platform, search for data sets, look at what's available in the data set, and request access to the data set. The request goes to the data custodian, the owner of the dataset. These custodians onboard the datasets onto the platform, but when they onboard them, we don't copy the data. We just index the data. So that's federated, as I mentioned earlier. What happens when the request comes is that the custodian can then see who the researcher is, what they're requesting access for, and approve or reject that. So they have control, they keep control, and data custodians really like that. The other thing the data custodians can do when onboarding the dataset is select specific fields to either exclude from the exports or to de-identify. And that de-identification happens when that approval happens. So if the custodian approves the researcher's request to the dataset, when we copy the data, we de-identify it on the fly. We don't write it to this first and then copy it to the cloud. We actually de-identify it in memory, and only then we copy it to the secure research environment. Make a copy of it at that moment in time, kind of a snapshot, basically. Then the researcher can access the data, but can only access the data on the trusted research environment. So they have to connect through a bastion or a jump box or a third-party service that provides secure access, and only work with the data in the context of the trusted research environment. There's very limited access to the internet, so they cannot just copy the data out. And when they're ready, they actually create a summary data, and that data is then put into a request for the manager of the trusted research environment to review it, kind of an airlock system. And then when they're happy that, yep, it's summary data, is what you say you were going to do, they can copy the data out. So it's completely managed under the same platform, from kind of a federated data catalog to de-identification on the fly, to trusted research environment, and to the final, export of the data when the researcher is ready to take it out of the system. So completely managed from beginning to end, and everything on your Azure subscription. I'm going to tell you about a couple more use cases. I'm going to jump to the demo right away. This is more talking about our automation. I said that there's certain workloads that are better for automation. This is a particularly interesting case because it's genomics, and that's something we do a lot. Path West is a public health lab in Western Australia, in Perth, and they were doing this analysis on premises. These particular analyses require GPUs, and GPUs, as you know, they're expensive, difficult to come by, and there are plenty on Azure. So what we do with the Loom platform is automation from beginning to end. We actually upload the data straight from the sequencing machine into Azure. We run an automated analysis using GPUs and the Azure Batch service, which is a high performance computing service. That's the team I was in, Microsoft Engineering. And then when the results are ready, we download that automatically to on premises. Not only do we do everything automated, so there's no mistakes and no time spent by the lab technicians doing this, but also we can do it up to 15 times faster. And that's because of the incredible GPU and compute resources we have on the cloud. And furthermore, it's a lot of data, and the data is just becoming bigger and faster in coming. So we actually move the data to archive storage because they need to keep the data for many, many years. And it's very, very convenient then to just put it in archive storage. And when they need it back, they let me know. And I provide a lot of research support to them. And finally, more on the custom side of things. Like I said, we also do custom implementations for research. We're working with a researcher in La Trobe University. They created a enormous amount of data from single cell RNA sequencing for agribio. And the problem was, once the data was analyzed, how do we interpret it? How do you understand the data? And they quickly realized they needed to visualize it. But the data was so big that conventional tools just didn't cut it. And there are lots of tools to visualize that kind of data and interpret it, but they just needed something very specific. So they came to us, and we did everything on Azure. So they upload the data, it's many gigabytes, and then we do a final processing of the data to prepare it for visualization. And that data then goes to a 3D visualization tool where the researcher can interact with it. It's literally a 3D space that they can interact and look at the data and interpret the results in a much more efficient way. With that, let's go to the demo so you don't have to keep imagining what this little platform that I've been talking about actually looks like. So a researcher accesses Loom by going to the SaaS service URL. When you first arrive on Loom, you're asked to authenticate. Like I said, we use B2B authentication. In this case, I'm going to use my work credentials because I'm already signed into Windows. There's single sign-on, but otherwise I would have seen the splash screen and, of course, the multi-factor authentication. And when I first come in, I see the projects that I own because I created them, or somebody invited me to be a co-owner, or projects that someone has invited me with a different role. Roles at the project level can be different. Like I mentioned earlier, I can be an owner. That means that I can add other people. I can remove people. I can deploy resources, obviously, but I also can change the budget and the alerts. There's also the contributor. A contributor is someone who cannot edit the project. They cannot add other people, but they can actually deploy resources and delete them. And there's a reader. A reader is like a PhD student, for example, or a lab technician for whom someone else deploys the resource and they are using those resources. They can stop them, they can start them, they can log into them, but they cannot delete them or change them. So that's the idea behind it. Because I'm root in this particular system, I can see all the projects, but normally you would see 1-2 projects, depending how many projects you're in. As you can see, very visible is the cost and the current spend, we call it, the current cost of that project, and the budget. And if I go into one of these projects, you can see that we also show the cost at the individual resource level. So every number of hours we go to Azure and say, hey, give me the latest cost for this. Now, costs, as you probably know, take a little bit to come in, but what we've seen is that compute in particular, the more expensive side of things, come very quickly. So we're always keeping track of that. And like I said earlier, if the budget is reached, there would be a warning. And if I try to go into the project, it would say, please contact your administrator. Now, In the context of a project, depending on my role, I can do different things. In this case, I'm an owner of this project. So I can not only use resources, but I can deploy resources. And that's done here. So I can add a workstation, I can add storage, and I can start add other resources. So normally you start with storage. We made it very, very easy to deploy storage. We just ask a couple of questions. Give me the name that you want to, identify this storage by, and then choose a quota. Now, I'm going to deploy one with 3 terabytes, but that does not mean that I'm going to start paying for 3 terabytes. I'm just deploying storage, which I will be able to use up to 3 terabytes, but I will only pay for the data that I put in that storage as I put it in that storage. So basically starts at zero and goes from there. Behind the scenes, what we do is we go to your subscription, we create a resource group. We already created that for that project. We create a resource group per project, and then we deploy a storage account with an Azure file share there. We use Azure file shares because they're very, very flexible, and that allows us to do things like this. For example, I've deployed my storage repository, and now I can click on Browse, and very, very easily from my browser, interact with that storage. I can upload files. I can browse files already existing there, and I can basically interact like you would with OneDrive or Dropbox or something like that. So it's a very, very natural experience for most researchers. Now that you have the storage, maybe you uploaded data, you might need to upload more data, especially if it's a lot of data. So browser is not very convenient for that. We also give administrators the ability to enable this capability of connecting to the data repository. What we mean by that is that we provide the Windows, Linux, or Mac OS script to connect remotely, and that enables the researchers to mount that locally on their workstation or laptop. Obviously, if this is a secure environment, you wouldn't be able to do that over the internet. You would need to be on the VPN or on premises or connected through Bastion to be able to do that, but you get the idea. Now, workstations are the next obvious thing to deploy. To deploy a workstation, it's also very, very simple. The administrator creates workstation templates. In this case, small, medium, large, a specialized one called with an application called AlphaFold, and then a Spot workstation. So you can also take advantage of Spot workstations with Spot VM, with Loome. When you select one of the templates, I might or might not, depending on the administrator choices, be able to select, for example, different sizes. A medium workstation in this case comes in 4 different sizes. I'm going to select the one with 16 gigabytes of RAM, 16 CPUs and 64 gigabytes of RAM, and then a selection of VM image. And these are a combination of images from the Azure Marketplace, but also custom images from your private image repository. So we can actually index and make those images available to the template based on your choices. So in this case, for example, I'm going to choose the Central IT Windows Server 2019 image. I'm going to give it some name. And then I'm asked for a username and password. Password have obviously to be secure and follow the standards of Microsoft Azure. I have the option to automatically mount a data repository like the one I just created, so it's available to me when I log into the VM. And I'm also given the ability to use the auto shutdown for virtual machines. I'm going to leave it with the default, which is a pretty good one. I should be going home by then. And then we do a quick validation and we deploy the VM. I'm not going to do that right now because that takes some time. I have a VM already deployed, a workstation already deployed. And you can see I can interact with workstations and with any resource with these kind of buttons here. There's always a manage that gives you information about what the workstation is. In this case, it's a B16. It has 16 cores and is using Ubuntu. I have the ability to mount a repository if I didn't select to mount it or I created a new repository when I created it. And then, of course, to delete it or change the auto shutdown. To connect to the VM, depending on what it is, if it's a Linux VM, you will receive, you will see this prompt. And you will be able to copy the SSH command to connect to the VM. And if it's a Windows machine, you would get the RDP command and actually the RDP file to connect to it. And the connection is pretty straightforward. But I'm not going to show you that one because we're going to connect to this HPC cluster that I created. In this case, I have two buttons. One is to download the SSH certificate to connect to it. So I can only connect when I have that is my SSH key. And the other one is to download, sorry, not to download, but to show the SSH command to use that key. And I've copied that. Now I'm going to open my command line. That key, connect. So now I'm in the cluster. As you can see, I have two partitions. One is a low priority, another one is a high priority. Low priority is spot instances, so we tend to do this by default. But this is just what that my administrator has chosen for this template, this particular template to have. If I look at the nodes, as you can tell, these nodes have 32 CPUs, fair amount of RAM, around 120 gigabytes of RAM. So that's pretty good. It's a pretty good machine. But more importantly, Nextflow is already pre-installed. That means that I can run Nextflow analysis or genomics pipeline analysis just by bringing my scripts here. And that would interact with the Slurm HPC scheduler, which will in turn interact with Azure. Now, even though it says here that I have a total of 20 nodes between the low priority and the high priority ones, those nodes are not deployed. I'm not paying for those nodes. They only become available when there's a job sent to the queue. So that means that the cluster actually grows and shrinks automatically based on what's on the queue. So you only pay for what you use. And this is fantastic for workloads like genomics, where you have a lot of little tasks that come and go. So you don't have to worry about, overspending, let's put it that way. The second thing is, if we look at what is mounted on the cluster, you can see that I have the Lustre file system mounted on this cluster. It's a 4 terabyte. So that means high throughput, low latency file system for HPC analysis. Very, very useful for all sorts of things, but particularly for high performance computing. And like the other things, you just pay for what you use. So when I'm done, I can just delete this solution, and I would have deleted both the cluster and the Lustre file system. Now, how do I get this? This is part of that catalog that I was telling you about earlier. So with time, you build the catalog, and a few solutions come by default, but in this case, Nextflow HPC is a very specific solution. As you can see, I have some data analysis workstations, I have some AI solutions, but this particular one is an interesting one because deploying an HPC cluster tends to be a complex thing, and many decisions to be made. In this case, the administrator has made it very, very easy for me. So I just need to give it some name. I can select the number of nodes that I want to deploy. There might be a limit, and the node sizes that are available to me. In this case, I'm going to select, like I did before, the one with 32 CPUs, but it could be one of the ones with HPC, and those would have InfiniBand behind the scenes if you need to do MPI or tightly coupled jobs. Then I might be given the option, in this case, of operating systems or not. Maybe the institution always uses Ubuntu or Alma, but in this case, the administrator has chosen two for me to select from. And then I can select different sizes of Lustre managed file system. So this is the service provided by Microsoft for low latency. It's just as simple as selecting a size. And then because they can actually copy and hydrate data into the file system when it's deployed, in this particular case, the administrator has given me the option to specify a container name, and they will copy the data automatically for me. And that's it. That's all I had to do when I deployed that cluster. Very, very simple, very, very repeatable, and a good way to start creating custom solutions. Maybe you need to create From this one, another solution that instead of Nextflow has SnakeMake or Galaxy, you name it, right? Or has, in this case, I have one for MATLAB parallel compute. So it's a cluster running Windows with MATLAB. So you probably get the idea. You build this catalog over time. Now, as I said earlier, we tag everything. So that gives you the ability to do this. You can go into your portal in Azure and create very, very detailed cost analysis reports and dashboards. In this case, I have two. One is every project in the last 12 months, by project, or by account in the last 12 months. So that's because, again, we tag everything. So this is Loome, and you've seen how it interacts with Azure. I hope that although short, this demo has given you an idea of how powerful and flexible it is. Finally, I just wanted to thank you everyone for attending. Thanks for your questions. And please, if you have any more questions, just send them to me. I hope to hear from you.
Thank you for attending today's session. Join the Microsoft Azure for Academic Research community on LinkedIn to follow this exciting new series where we will post announcements about monthly presentations on cutting-edge research-focused topics. We hope to see you at the next session, and thanks again for joining.